So next we want to go to Falcon space. I want to talk to Mark.
So there's not that many updates from the lab. We're still waiting on the 3D printer that we need for the Alzafon experiment to finish up the tuned resonance chamber where the sample is going to be held. We did get in this sample of this metal over here, which I'll show you my hand. This, for those of you who don't know, it's slightly bluish. This is osmium. And we're going to make a gravitator out of that. T.T. Brown in his patent mentioned that the heavier the material used, the stronger the effect, and osmium is the densest metal. So why not just go for broke and shoot it with osmium? Another thing we were talking about, me and Jeremiah, was that we don't actually have a warp drive detector in the lab or a laser interferometer table. Which is, the go-to way to detect these kind of fields. So we wanted to set up a laser interferometer or the warp drive detector or the UFO detector, whatever you want to call it. The problem is that most of these tables are made out of metal, and a lot of the experiments involve high voltage, so we couldn't use that. So we did some searching around, found the stiffest plastic composite we can find, and it's sitting right here next to me. This stuff can hold 45,000 pounds per square inch or something like that without deforming. Has extremely stiff plastic that arrived here at the lab on Friday. And we're going to set up some laser pointers and stuff on it, and we'll have carry handles on it so we could just move it around to any experiment and see if there was any effect that we didn't notice. And we'll have to try some of the older experiments too, because there might have been something there that we didn't notice. Another setup that we're going to have on this board is a wavelength detector. So we're going to have I think he recommended the neon laser or something like that, or the helium laser that has a very steady frequency output, very clean, steady frequency output. And then you have a frequency detector on the other side, so we can check if there was any change in frequency, and we have the laser output coming from inside wherever we suspect the field would be. So if there's any change in frequency, then we'd know that there was an expansion or contraction of space-time in that space. Again, like I've said many times in the past, I'm not convinced that warp drive even exists, but this would be the way to detect it to the best of our ability. What else do we have going on in the lab? We got a new vacuum pump over there that came in from San Diego. I still need to get the connectors for it. And that's just for general lab work. And well, hope to have some actual experimental updates in 2 weeks from now. We're going to get the printer in on Monday or Tuesday, and we're going to use that to print the inside of the tuned cavity for the Alzafon experiment. For those who don't know, Alzafon is basically a way of creating a coherent matter state where you orient all the subatomic particles along the same spinning axes, and that should theoretically make the craft weightless along its spinning axis. And as Einstein said, nothing can go faster than the speed of light. Well, that also means that if you make the craft weigh nothing, it can go faster than the speed of light. So how do we make it nothing? Dynamic nuclear orientation, according to Alzafon, should do the trick. And that is something that we're working on. Also, I have behind me a massive, right over here, this is a massive electromagnet. Weighs about a ton, and it's on caster wheels, so we can move it around. Here's the power supply for it. And behind it over there, you can't really see it, is the Klystron. That's the microwave energy source, and over here is the Klystron power supply and the signal generator and the signal analyzer, and also the forward and aft power meter using a cross guide. So that's what's going on in the lab. Not much. There was a couple experiments that we did over the last 2 weeks, mostly with Jeremiah and Wayne Ojala out in Canada, and Nam-Tran in Vietnam was doing some experiments as well. There's also another interesting update. There's a new member of the Falcon space team. His name is Charlie, and he's a PhD electrical engineer working on the Alexei Cherkov gravity flyer device. And this is something that we've been a little skeptical about. Some people think it's a fraud, that he's a fraud. Alexei's videos of his spinning device is fraudulent and doesn't really work. And some people think there's something to it. But I'm kind of on the fence on that. But if anyone is willing to do the work and actually build a device, I'm totally game, totally helping them, because that's the only way you can find out. Alexei's not really responding much to our inquiries, and he keeps on pushing us to look at Grabinikov, at Hutchinson and Searle, and like, I don't really know where that goes. There was another guy on Facebook who was working on this device, and he apparently got, this was very obscure, we didn't hear about it until recently, and he apparently got 80 grams of weight loss in his testing device. And unfortunately, he passed away recently from a heart attack or causes unknown, and he was working on the device at the time. We're in contact with his widow about getting that device and setting it up here in the lab inside of our Faraday cage so that we can replicate his work and continue it on. I think his name is Chris Hartman or something like that. We'll look into that, and if we get that device down here in the lab, we'll definitely turn it on and replicate as best we can, look into all his notes and try to continue where he left off. There's a good reason why there is a heart start defibrillator here in the lab, because a lot of these experiments are very dangerous. So that's just a reminder to anyone out there who wants to work on this stuff. You should have a lab partner, and you should have a defibrillator on hand, for dealing with the high voltage components. And yeah, it's pretty much what's been going on. Any questions?
Awesome. Well, I actually have a question. Now, when you mentioned the laser interferometer, for me, that's exciting. And I think Sonny White had mentioned this too, right, over at NASA. And the idea is, hey, maybe we are modifying gravity. Maybe we're modifying time space. And there's sorry, Jeremy Reese is trying to butt in. I was teasing him in chat. So maybe we are doing these things. How do we know? How do we measure it, right? If you guys are able to get that, it would be not only would it be amazing to measure your experiments, it would be very interesting to take stuff like electric motors, electric light bulbs, God knows what, anything that's lying around the lab, right? Maybe common devices are modifying time space a little bit. I've never seen anyone do real testing on that. Who knows?
And also, all laser interferometer tables that you can find commercially are made out of metal, which would interfere with all these experiments, which is why we needed to go with plastic. This is a plastic composite, so it has a pretty high, dielectric strength. But it's the stiffest stuff we can find, and I think it's even better than the aluminum tables that they have offered, with its stiffness. It's 2 feet by 3 feet. It should be more than big enough to move around the lab, put it on any experiment, stick it on top of the Tesla coil, whatever you want to do. It's not going to interfere with the experiment. It's not going to interact with it, but it will give us results that we can quantify and say, we tried this experiment. We also put the warp drive detector on it and saw this, saw that, whatever.
Now, if I could jump in real quick, Mark, as I recall, in discussion or in chat, or we have so many channels, right? I don't remember where this was, but I think there was a talk about remote, because right now the table, that's kind of up close, but wasn't somebody talking about some kind of a remote distortion detector also, right? And I'm thinking about UAPs here. It would be neat to have something that you could point at a UAP or point at a light in the sky and say, something's going on there.
No, I'm not really familiar with a UAP detector. No.
Yeah, I don't know. I know that there is the proton magnometer. I believe that was one of the things. But Will has his hand up. Will, go for it, sir.
Yeah. Sorry. How large is the model you want to 3D print?
It's not just the size of it, it's the accuracy, and they're quite small components, but we need a 3D printer here in the lab in order to modify it, because you never design it correctly the first time. Yeah.
Well, I have 2 industrial 3D printers right here in my room.
So, where were you located?
Japan.
Yeah, I have a 3D printer in the other room. I actually got into 3D printing like 7 or 8 years ago. with the Solid Doodle 1 and 2. That company's out of business already. And then I got the cheap Chinese CDC one. This new printer that's coming in should have an accuracy of up to 10 microns, which is extremely accurate. And it's like a custom small company that builds these highly rigid ones. So we're really excited about that. I actually use 3D printers to build equipment for the hybrid battery shop. So there's, I've been
Raise 3D and Epsilon W50.
Yeah, I'm pretty much going to be printing. I think we're going to be printing ABA plastic, which has a very high dielectric strength. We're going to be printing like these squares or rectangle shapes, and we're going to use those to shape the waveguide chamber and see if it's in resonance or not. And if it's not in resonance, all you can do is print another one or cut it down and make it smaller. It's all you can do.
ABA or ABS?
ABA.
ABA.
ABS is a common plastic. This is not a common plastic.
Yeah, I don't have that on my list. So I'll have to take a look at that.
It has a very high melting temperature of like, I think it's like 250 degrees centigrade or something like that, or 270 for the nozzle temp. It's a very high nozzle temp. Right.
Okay. I'll look into ABA. That's interesting. Always good to learn about something new. Also, if you guys happen to be interested in vacuum chambers that can cut out the Earth's magnetic field, I have a couple extra ones.
Oh, yeah, we'd be very interested in that.
Something I can work out with you on that. We can talk about that later.
Yeah, it's made out of mu metal, or
it has mu metal lining.
Really cool. Yeah, how big are they?
One of them is 2 meters across internally. And
oh, wow.
And the other one is about, I think, 30 centimeters.
Well, 2 meters across internally, that's large enough to run a lot of experiments in. Is that round? Is it a ball, sphere, cylinder?
It's a cylinder, yeah.
Wow.
It has a lot of ports. So
that's
okay. Well, Will, do you have Mark's contact info?
You can respond to the email.
So
you could just respond to the email invite that goes right to me.
Okay. Yeah. That email that goes out, that will come back to Mark. Okay. Well, so do you want to go to open discussion session now? Or
if anyone has any more questions, or you want to discuss any of this stuff further.
Okay, let's do that. Yeah, no, I think it's kind of a light day today, right? But it's the day before Easter, so and I guess it's Judeo-Christian holiday. I guess everybody has.
I think Ron has a question.
Oh,
Ron,
does he?
Yes. Hey, Ron. Come on.
Where's
Ron? Unmute yourself, Ron.
Let me find Ron.
Put the glasses on. Yeah, put on your warp drives. Technically, glasses, according to some interpretations, glasses are warp drives because they.
Okay. No,
right?
No, different thing. I heard it gives you a 10-point appearance on your IQ. So I need it. I need a 10-point uplift on my IQ. So the thing is, I see you have elemental osmium.
Yes.
You have elemental?
Yeah, it's pure. It's the metallic version. We plan on melting it inside of a vacuum chamber using induction heating. Actually, that was something else I was going to talk about.
Yeah, the thing is, since you're duplicating Brown used, as you know, litharge. He used litharge, which is lead oxide. So do you plan on taking that to? I'm not sure how easily osmium is to oxidize. It looks as though it might be difficult. Do you plan to?
No, it's actually very reactive with oxygen. When you warm it up, it grabs 4 oxygen atoms, making osmium quatrooxide, which is extremely poisonous and deadly.
Oh God, yeah, and that's why. But like I said, because Brown used lead oxide is not really that great either, but probably not as bad.
Osmium quatrooxide is extremely dangerous. Which is why we're going to have to melt these into plates inside of the vacuum chamber so that it doesn't come in contact with any air. We're going to use, what do you call it? We're going to use induction heating system that we
Okay.
set up in order to warm it up. And then we're got ceramic plates to withstand the heat. It takes 3,000 degrees centigrade to melt.
Yeah. It's getting toasty.
Very hot and toasty. Yeah, but inside a vacuum chamber, it's not so bad because there's nowhere for the heat to go.
Yeah, another item on Chekhov. I'm friends with Alexander Frolov, and I always ask Frolov about Chekhov, but I don't know. Frolov has said negative things about him, but sometimes they're competitors.
Yeah,
Because there's something called
we had Frolov in the chat group at one point, and he gave us this design for an experiment we called Frolov's hat.
Yeah.
And it didn't work, but he's a very colorful character, to say the least.
Well, also, if you look on YouTube, there is, I'm not sure what nationality. He might be Taiwanese, Chinese, but there is a reverse engineering of the Chekhov device, and the guy goes through it component by component for 2 hours. Have you ever seen that?
Send me the link. I might have seen it, but send me the link. Yeah,
Because
definitely.
he spends 2 hours on it, going through each individual component that he sees there. What worries me is why they use such a large air gap and neodymium. To some degree, why do you use large air gaps? But anyhow, okay, I'll beam it to you. And also, I sent to Tim the Silpho Moore and its involvement with the University of Manchester. It's really interesting. I had 4 pages I sent to Dr. Frank Mead, and the page that I want the most somehow disappeared. But the 3 pages there are metallurgical. And like I said, as Manchester University and their Ferris laboratory analyzed these materials and why it never got to public. So, okay, thanks again, Mark. Be careful.
Will do. Thank you, Ron.